29th. Okay, so that's the division and subtraction rule. This next one I'm going to write as I'm going to call it the x coefficient / exponent rule. Okay, if I have log of a to the k, so if I have a log of a number with an exponent on it, I can move that exponent where? Where can I move the k? Where can I move my k? Okay, I can make it a coefficient. It becomes k times log a. Yeah, it is really hard to see. Yeah. I kind of want to keep it a different color though, because it kind of looks nice. I don't know. Oh.
It's the light.
Here, I'll do double. There you go. There you go. You can see it, but it still looks different. There you go. Okay. I don't know if we'll need this. No, we probably will. We definitely will need it though. I don't know. I'm not sure if it's in 3.4. Change of base. You probably can't see that, can you? Okay, change of base. Change of base. Change of base rule. Anyone know how to change bases? Okay. So log base b of a equals, someone give me a number, your favorite number. What? Raise your hand. That's it, Colleen? 13, okay. That's the same thing as log of base 13 of a over log base 13 of b. Okay? Someone else give me their favorite number. 7, okay. That's the same thing as log base 7 of a over log base 7 of b. Someone else give me the favorite number.
10. 35.
35. Same thing as log base 35 of a over log base 35 of b. Okay, now the marker's running out. So the change of base, you can pick whatever base you want, okay? The log of base b of a is the same thing as log a over log b with any base you want, any base. That's like the logarithm Bible right there. So write those down. Okay, so part A right there, part A. Okay, how do I write these as a single logarithm? How do I combine them? What rule am I going to use? It's log x minus log y. Let me look at the board and see which rule. Yeah. So this is the same thing as log x over y. Good job. Okay. B, for part B. I got to combine those two, right? What are we thinking? There's a plus, right? Which one of these involves a plus? Sum to product rule, but there's just one little pesky little 2 right here.
You have to do 2y.
What's that?
You have to do 2y.
You would need a 2 here. Well, how can we get rid of this 2? Or, no, how can we move it to the inside? We want to use the coefficient exponent rule and take this 2 on the outside and move it in. Okay, so we rewrite this as log x squared plus log y. Now, do you guys see how we can seamlessly use the sum to product? Okay. All right. Okay. You guys see that? So I wanted to combine them with the sum to product rule, but before I did that, I had to get rid of the 2. Okay. Well, I had to get rid of it. What I did was, I can't just throw it away. I had to just move it to the inside. Okay. All right. So that's the answer to that one. C. 1/3 log z plus 2/3 log w. All right. We're going to do what here? Same thing, exact same thing, right? So we want to use, there's a plus here, so we want to use the sum to product rule. Before we do that, we need to make sure they either have the same coefficient or their coefficients are gone, okay? So to deal with the coefficients, we use the coefficient exponent rule, okay? So I'm going to take this 1/3, stick it in here, 2/3 goes in there, okay? So log of z to the 1/3 plus log of w to the 2/3, okay? That's what it becomes. And then last step, that sum to product rule, log z to the 1/3 times w to the 2/3. That's my answer. Final answer. Final answer. Okay. Some more water. You guys okay if I move on to D? Okay. Okay, there's a minus here, so I'm going to probably end up doing what? Yeah, the division to subtraction rule, okay? I got to get rid of those coefficients, though. How do I do that? Oh, sorry. How do I get rid of those coefficients? Yeah, same thing, yeah. So log of 16 to the 1/2 minus log of 8 to the 2/3. All right. What is, so that becomes log of 16 to the 1/2 over log 8 to the 2/3. What is 16 to the 1/2? 4, yeah. And what's 8 to the 2/3? Let's talk about this. 8 to the 2/3. What did we say? 8 to the 2/3, right? That's the same as doing 8 squared rooted to the 3rd. Okay, what's 8 squared? 64. What's the cube root of 64? 4. Okay. So 8 to the 2/3 equals 4. Okay, what's 4 over 4? 1. What did I say when you have log of 1? What's log of 1 always equal to? So 10 to the what equals 1? If you raise a number to the what, you get 1. You guys know this. 0. Yeah. So our answer is 0. Wow. That's really cool. E, we're going to use the sum to product rule for E, the sum to product rule. Okay. So we got to get rid of what then? Coefficients, right? We got to move this 3 inside, move the 1/2 inside, okay? So we get ln of 2 to the 3rd plus ln of 36 to the 1/2, okay? So I just move those coefficients inside, and then that becomes ln of 2 cubed times 36 to the 1/2. What is 2 cubed? 8. What is 36 to the 1/2? 6. So it's ln of 48. ln of 48, okay? So these problems are all very similar. F, what am I going to end up using? All right, do some cold calling. F, for F, what am I going to end up using? Elise Neal. Yeah, exactly. Good job. Yeah, good job. So I moved that 4 inside here to make it an exponent. So it's going to be log. Now xy raised to the 4th is the same as what? It's x to the 4th, y to the 4th. No. So make sure you put the coefficient on both variables in there, okay? And then that's going to be a minus log of what? X cubed. Yeah. Okay. And then this becomes a division, right? So log of x to the 4th y to the fourth over x cubed. Okay. What is, and then that simplifies to xy to the fourth. All right, taking this white road. All right, so that's it for that part. Okay. Can we do heading 2 now? Expand. So now we want to go the opposite direction. Right? We want to write these as multiple different logarithms, okay? So ln of x times y, which rule involves multiplication? Yeah, the sum to product, okay? So ln of x times y is going to equal what? Ln of x plus ln of y, okay? Okay, so it becomes multiple logarithms. Okay. All right, for B, which rule we're going to use? Ian Jackson.
Change of base.
Not going to use change of base. We just need to write it as multiple different. So like you're on the right track, but change of base, right, has 2 logs over each other. This has a log of just one log of like 2 things. So we're going to use what then? Yeah, good job. Yep. So this becomes log of x cubed minus log of y to the fourth. And let's to practice using what's that?
Can't you add it more into like 3 log it?
Yeah, that's what I'm saying. That's what I have to say. So let's practice using the coefficient exponent rule and pull these exponents out and make them coefficients, okay? So that becomes 3 log x minus 4 log y. All right. This one, C is a little different, okay? I can't immediately jump into my subtraction rule, okay? I can't immediately jump into it, okay? How do I deal with that 5th root? That's called a 5th root symbol. How do I deal with that? Yeah. So I don't have a rule here about like radicals. I don't have a rule about these checkmark symbols, but I do have a rule about the exponents, right? And rooting something to the 5th, as Jack French is saying, is the same thing as raising it to the 1/5. Okay? Then what can I do with that 1/5?
Cut it out.
Yes. Okay. Then what does that log x over y become? What did I do wrong there? Yeah, I need you guys make sure you put the 1/5 on both terms, okay? I think that could be a really easy algebra mistake to make on a test, on the test. Right? Okay. That could be a really. So that's it though, right there. Can I do part D? I bet it's pretty far away. Part D. We want to change that check mark with a 4, that 4th root, to a what?
1/4.
Yeah, you want to change it to a 1/4. It's easier to work with exponents here. Okay. What rule do we use, Rylan, to rewrite that logarithm as 2 different logs?
The division, subtraction.
Yeah, so this becomes what?
Log x minus log.
Don't forget that 1/4 exponent, okay? And how do I deal with that exponent, Rylan?
Just multiply each log.
So what's the green slash What's this one? Coefficient exponent rule. If I have an exponent, it can become what, Rylan?
It'll become, the exponent of.
So this exponent I can just move to the front right here and make it a coefficient, okay? Does that make any sense? So that becomes 1/4 log x minus log y. Okay. Can I move on to E? I have who wants to walk me through this one? Let's have Silas Mills walk me through this one. Or E.
Alright, so you can take the exponent, can you put that in front?
Not yet, and that's because the exponent is only on x. If I had an exponent on 100 as well, then I could. Okay? So I'm going to do what first? What's that? Get the 100 out of the way. How do I do that? So this is 100 times x squared, right? That's a little hint. What can I use now? Term division, yeah. Yeah. That's what that becomes, okay? Then I can do what with the exponent? What's log of 100? Log with no number is the same as what? Log base 10. What's log base 10 of 100? 10 to the what gives me 100? Yep. This is 2. Can we move on to F? Matty Hewer. Walk me through F. That's a good idea, but I can't do that, and that's because the 3. So if you have, in order to move the exponent to your coefficient, it has to be the exponent of everything inside your parentheses, okay? 3 is only the exponent of E. So what would I do instead? There's no x here, so we got the first part. So this is 30 times e cubed, right? What can we do when there's a product inside of a logarithm on the board? We're on the board. What the board tells me to do. It's not the change of base. When there's a product inside my log, what does it say? So log A times B equals log A plus log B, okay? So this is log of 30 times E cubed becomes what? That's like later. That's the coefficient exponent rule. So what's my? Someone help her out. What two things are multiplied? What are my two factors inside my log? 30 and e cubed, right? So then it becomes the sum of the log of just each of those. Okay. So the two factors here, right? This is that pink 30 times that blue e cubed. So what this is going to become is the log of just that blue e cubed plus the log of just that pink 30. Does that make any sense? Okay. So you got to practice our sum of product rule. And then Maddie, what can I do with that 3 then? That next term? Yeah. So those cancel out, as Maddie was saying, so it's 3 plus, and then we can even go farther with this one. If we rewrite, we can rewrite 30 as ln of 2. Let's do the prime factorization. 2 times 5 times 3. This can become 3 plus ln 2 plus ln 5 plus ln 3, okay? That's if we go crazy with our logs. Okay. Alright. Okay, so that's everything for expanding and combining. Okay, so let's just make sure we know our sum to product rule. Alright, evaluate, round to the nearest 10,000. Log base 3 of 4. Log base 3 of 4. Anyone have any ideas how to do these? Have any ideas? I know multiple ways to do these, multiple ways to do these. Let me show you the right one. Well, one way you could do it is by plugging it into your calculator, okay? So let's do log base 3 of 4 in our calculators. Okay. All right, one way. Okay, so how do I do that? Where's the log base 3 button here? Anyone see a log base 3 button on my calculator? There's log, that's log base 10, right? Or I could do ln, but that's log base e. Okay, so there's no log base 3 button on my calculator, so what do I have to do then? So there's no log base 3 button, but there is a log base 10 button, right? You guys see that? So what you do is, right, we want to rewrite this. So we want to rewrite using a base that's on our calculator. Okay. Okay. So we want to rewrite this using base 10 log or base e logarithm. Let's do base 10. How do I rewrite with a different base? I have to change the base, right? I have to change the base of this logarithm, and I do that with my change of base formula, okay? So let's pick a new, so it's going to be my new base. I can pick whatever I want, so I'm going to do base 10, so it's just going to be log over log, okay? And then it's going to be 4, log of 4 over log of 3, okay? All right. Now we can do that with our calculator. So log 4 over log 3. Okay, you guys see how I'm doing this? So 1.2619. And that's my answer, okay? All right. Okay. So you guys see how I use change of base formula? Right? I can do it again with b, right? I can rewrite this as the sum log of 3 over sum log of 29. Okay? So this is the same thing as log base 10 of 3 over log base 10 of 29. Okay? Let's do that in our calculators. Hey, you see how I'm doing my calculator? I'm just pressing the log button. Okay, that gives us 0.3263. Okay. All right, let's whip through the rest of these. Let's have someone walk me through. Let's do Madeline Shetty. Good job. And what do you get in your calculator, Madeline, when you do that? 2323. Good job. Yeah. Let's have Ali Mendoza. Can you do D for me? So you're close. We just need to flip-flop these around. So it's the log of the number inside the logarithm over the number over the base. Okay. So it'd be log of 16.9 over the log of 5.1. Does that make sense, Alan? Okay. Can you do that in your calculator for me? Awesome. 1.735. Is that what you guys got? Looks good. Looks good. Let's do Caleb Martin. What's this one equal to? Log 17 over log, and that's 0.3, but it's hard to see. You got your calculator for me? It's up right. It's up right. Why don't you intercept Ben's?
It's already on.
It's already on. Negative 0.4249. That's right. That's right, because this log in the top is going to be positive, and this log in the bottom is going to be negative. Because you have to raise 10 to a negative number to get a fraction. Okay, so that's the answer there. Let's do this one, part F. Maggie Melbrook. Good job. What's that equal to? 4919. Good job. Awesome. Okay. All right. There you go. Some applications of logs there, Jack French. Light intensity in Lake Superior. There you go. Anyone ever been to Lake Superior? You been to Lake Superior? Super cool place. Very cold. Very cold. Except in western Michigan, there's kind of like a section where it's like very shallow, and it's like the bottom is like this like weird like red rock, and that's a little warmer. But the rest of it is absolutely freezing. Yeah. You're from Alabama, right?
I was born in Michigan.
You were born in Michigan. What part of Michigan?
I was born in Southwest Michigan.
Southwest. Like Grand Rapids.
So close to that.
I used to live there.
Nice.
It's probably 4 years more. Okay, anyway, A. The relationship between the intensity of light in lumens at a depth of x feet in Lake Superior is given by this formula. What is the intensity at a depth of 10 feet? Okay, so they give us this, okay, so the log of the intensity over 12 equals negative 0.0125 times our depth, right? X, they say, is in depth, okay? what they're asking, what is the intensity at a depth of 10 feet? So did they just give us an I or an X? They gave us an X, right? Because they gave us a depth. Thank you. And X is depth. Okay. So let's plug that in. Okay. And then we just need to solve for I. Okay. So let's do that. Let's simplify the right side. Okay. All right. Okay. There's multiple ways we can do this one. How do I want to break that I out of the logarithm? So it's a log base 10, right? That's a base 10 logarithm. 10, yeah. So the 10 to the left equals 10 to the right. Okay. So I over 12 equals 10 to the negative 0.125. What do I need to do now? Just got to multiply by 12. Okay, so I equals 12 times 10 to the negative 0.125. Let's do that in our calculator. Okay, so I put that in my calculator. Okay. All right, that's 8.998. Let's just run up to 9. The intensity is 9 what? Lumens. Nine lumens. Okay. All right. B, earthquake intensity. The Richter scale. There you go. The Richter scale of an earthquake is based on the features of this seismic wave is measured by this, okay? So, what they're doing is they're having you calculate the magnitude using this formula, given these values for A, T, and B. So we really just plug and chug here. You guys see how it's just like a plug and chug? So it's just R for this first one, it's going to be R equals log of 250 over 2 plus 4.25, okay? Plug and chug that in your calculator. Second one is going to be R equals log of 300 over 4 plus 3.5, okay? Let's just plug and chug that in our calculator. So there's the first one. Okay, that gives us 6.3469. What's the unit? What are the units for that? What's R? R is just mag. I think it might just be a number. Hey guys, some physical quantities are just like a number.
I think it's just
yeah.
Oh, where the amplitude is micrometers.
Amplitude is A, right? And they're asking for
Yeah.
R. We just calculated R. R has no units, I think. Yeah. Some physical quantities don't have units because they're a ratio, and ratios don't have units. That's like a physics lesson. Ratio, yeah. What's your ratio? All right, and then let's plug and chug the second one. $5.375. All right. One thing I want to say is I think the most useful application of logarithms. There's a lot of like nuclear power. There's a lot of nuclear power applications. Okay. So you use logarithms to calculate like the amount of power that's going to come out of like a nuclear explosion, or like if you're doing it for good, like the nuclear power. All right, hey guys, good job today. 3.4 homework for next time. Yeah, I got 3 minutes left.